Hello, everybody. This is going to be the week 7 assignment that I'm going to go over. The first thing I'm going to do is I'm going to go over the linear, quadratic, and exponential equations and how they can be written. Right. So we have linear equations, and they can be written like this. This is the most common that we do in algebra. I don't want to do equals. Linear. Y equals mx plus b. Remember that the m is a number and it's the slope, and b is also a number and that is the y-intercept. Okay, so as long as you have a number with an x and then plus or minus another number, that is linear. That's the way we write a linear equation. So let me give you some examples with numbers so that you can kind of see how that looks, because on questions 1 through 3 on the assignment, I believe, that is what you're looking at. So a linear equation could look like something like that. It could be a fraction. Anything like that. Remember that if there's no number in front of the x, technically it's a 1. But when we do math, somebody decided a long time ago, hey, we don't need that 1. We're just going to leave it as an x. But that's still a linear equation. It's mx plus b. So those are some examples of a linear equation. All right, so then we have quadratics. And if you remember, the quadratic equation was ax squared plus bx plus c. And this squared is your clue. If you see anything to the squared power, then that's going to be a quadratic equation. When we did linear, it was y equals mx plus b. There was no squared anywhere, only when we do the quadratics. So that is your first clue when you're looking at, that you're trying to identify what kind of equation it is. That's what they're trying to get you to learn, is if you see mx plus b format, it's linear. If you see the x squared format, that's going to be a quadratic. So it could look something like this. You could have like 3x squared plus 2x minus 3. Because remember, a, b, and c are all numbers. And remember, when we use all these letters like a, b, and c, m, b, those are called variables. And any variable just represents a number that you don't know. Once you find out the numbers, you just replace the letters with the number. So if we were going to identify a, b, and c, it'd be 3. A is 3, b is 2, c is -3. So anyway, that was a little review for quadratics. But for this lesson, you need to just pay attention to, if you see the squared, that's going to be a quadratic equation. You could also have an example like 3x minus 2, 3x squared, excuse me, minus 2. As long as that squared is there, that's a quadratic. And what they did on this one is they just took the b out, the bx. It's just missing. But the squared is your clue that it's a quadratic. You could have -2x squared plus 3 minus 8, 3x minus 8. That would be a quadratic. And I'm just coming up with just random numbers. -5x squared minus 3x plus 2, that's a quadratic. But you know it's a quadratic because they all have that squared in there. Okay, so moving on to exponentials. There's a lot of different ways you can write exponentials. You've seen a lot of different ways, and what we're really trying to get y'all to learn is that they're all exponential equations, but there's about, or the ones I'm about to show you are all exponential equations. There's just different ways that you can write them. So one of the ways is just y equals a times b to the x. Another way is y equals a times b to the x. They sometimes don't use the parentheses. And these, in this assignment, this is the, I think this is the main way they show you. But notice how the exponential equations always have to the x power. Quadratics had to the second power, but exponentials will have to the x power. So if you see anything like y equals 3 times 4 to the x power, that's an exponential equation because it's got that to the x power. It could look like this too, y equals 2 times 8 to the x power. But as long as you have to the x power, you're good. While we're doing the y equals part, let me remind you that anytime you see f of x equals, that is the same thing as saying y equals. So I could change it right here. And I could just say f of x equals. F of x equals. It's the same thing as saying y equals. F of x equals. So this f of x equals is the same thing as saying y equals. So don't get mixed up on that. You're not doing with anything with the f of x. It's the name of the graph. They use different letters sometimes. Sometimes they'll call it f of x equals. Sometimes they'll say g of x equals. And y'all should be familiar with this because we've seen this in class. Whoops. Sometimes they'll say h of x equals. If people want to do something with the f of x or the g of x or the h of x, it's just there. It's just naming that graph. So if you graphed one of the graphs and you would name it, that's the graph f, and then you would graph another graph and you could say that's the graph g, so people know which ones you're talking about. That's why that's done. Okay, but getting back to it. F of x equals is the same thing as y equals, and that's going to be important because that's the way it looks in lesson 7. All right, I'm going to leave this how it is. I'm going to jump to the assignment. Okay. So I'm sharing my screen right now. I got to kind of move my little cursor real quick. And we're going to look at the assignment for the week. So when we're looking at the assignment on number 1, see, there's that f of x equals. Don't worry about that. That just is naming the graph. We're only concerned with what is after the equal sign. So we already went over these linear and exponential and quadratic functions. If you look at number 1, it says 3x minus 9. It's just a number with x and then another number behind it. And we talked about which one that should be, linear, exponential, or quadratic. Number 2 has that 3 to the x power, and we just talked about that. Now, number 3 is not asking if it's linear or exponential or quadratic. It's asking something else. It's asking, does this equation open up or down? Does it have a maximum or a minimum? Now, if you look at your notes that were provided to you, if there is a negative in front of the x squared, it is going to open down. But if there is not a negative in front of the x squared, it is going to open up. And then I'll talk to you here in just a second about a maximum or minimum. I'm going to show y'all a nifty little website that you can go to called desmos.com. If you have a regular TI calculator at home or you are able to download it on your computer, use that. You're used to graphing these. Remember, only just put in whatever's after the equal sign and it'll graph it for you. But if you do not have a TI calculator at home, you can go to desmos.com. And if you just Google it, Desmos, and look, it says graphing calculator. So if you go to the graphing calculator on Desmos, you get this that shows up. And our problem was, remember, I'm not worried about the f of x, or I'm not worried about the f of x. I'm only worried about what's after the equal sign. So that's what I'm going to put in here. And hopefully I'm not a liar, but I might be. So we'll see. And they have this little calculator button, and you can just pop it up. So x squared, and then minus 9, and you get your picture. And you can kind of zoom out. And if you notice, this is where you can see whether the graph opens up or opens down. What you have to think about is if it opens up, it looks like a smiley face. If it opens down, it looks like a frowny face. And the way I have some of the students remember is when you're feeling up, you smile, and when you're feeling down, you frown. So this is like a little smiley face, the red line that you can see on the screen. So this is going to be opening up. Now earlier I said if there's a negative in front of the x, it will open down, just like a frowny face. And that's going to be important for when we get to lesson 8. Just a little heads up. Oops. Well, it's doing weird stuff. There we go. So just remember that you can graph that in. Let's see if we do like +5, still smiley face. So that's opening up. Now, number 3 also asks, does it have a maximum or a minimum? Well, that's talking about the vertex, and that's that point at the very bottom. Right now, it's giving me the coordinate point for the vertex. And all you have to do is you can press anywhere, and it'll give you the coordinate point. It has to be pretty specific, but you can hold your, I have my stylus, so I'm just kind of holding it over. But Desmos, you can also plot these points. So the vertex is where I have that dot right now. Right now, it's not asking, the question that we're asking is not asking for the coordinate point. It wants to know, is this a maximum or a minimum? When the graph has a smiley face, you have to remember when we look at graphs, we look left or right. If you pretend that this graph starts on the left and a little man starts walking down the hill, gets to the very bottom of that vertex, that's a minimum because he goes to the bottom of the hill before he starts walking back up the top. If, let's say, this had a negative in front of it, and we flip it, now it's the other way. If we read this graph left to right, the man would start on the left and start walking up the hill to a maximum and start walking down the hill. So that's why it would be a maximum, because it's like you reach the top of a hill. But if you don't have like that, then this is going to be a minimum, because you got to think the man has to walk down the hill. Okay? So that's number 3. Let's see. Number 4 is stating what is the y-intercepts and the vertex. Remember, I just talked about the vertex. That is the bottom part of the graph. And when you answer number 4, it needs to look like this problem, where you put in parentheses, you do the x value and then the y value. The x value is 0 because the x-axis goes left to right. When we start in the middle to plot that point, we don't go anywhere left or right. We just stay right at that 0, right in the center. That's a 0 point. So that's why the 0 is there. Then the next value is our y value. The y-axis goes up and down. So we went, and on this graph, it's jumping by 5s. It's not going by 1s. So sometimes you have to be careful about how this is being counted. It's not always going by 1s. So just be careful about that. So we went from 0 to 5. So that's why that point is at 0, 5. Remember that the y-intercept is where the graph that is drawn, the smiley face, touches the y-axis. So here, let me stop sharing that. and then go back to my whiteboard. Let me show y'all a few examples of how we graph certain things. Because that was one major thing that people struggle with, is how to graph. And you can do some YouTube videos on how to graph coordinate points, but I'll do a little demonstration. And I'm going to draw this. It's not pretty, but it'll do. So the vertex should be at the very bottom. So let's just say I make some coordinate point or some marks here, and we're at +3 on the x-axis, because that's going left and right is the x and the axis. Down here is the y-axis going up and down. Let's say this is like at, I don't know, -2, -1, -2. So that point is at +3, -2, because when we plot points, we do it x value, then y value. On the x-axis, I went 1, 2, 3, so 3, and then I went down -1, -2, and that would be my vertex. This is also called, on this type of graph, the minimum, because we started from left to right and we went down the hill and we got to our minimum. So then let's talk about the y-intercept. The y-intercept is right here. So I'm going to do y-intercept. That's where this graph that I drew touched the y-axis right here. So my point would be, it's not going to be perfect either. I didn't go anywhere on my x-axis. I just stayed in the middle. So that's 0, because I didn't move left or right. And then I went down -1, and I'm kind of in the halfway point, so technically I could just kind of say it's -1.5, and that's my point. But that's how we graph those, and there's some vocabulary there. So this point is our vertex, and in this case, since it's a, what do we call it? Since it opens, up, it's going to be a minimum, or your vertex. That's what you're going to call the vertex. It's called your minimum, because the man walked down the hill. This right here is your y-intercept. It's where the line touches the y-axis. Okay? So let me get back here. Okay. And then what are 3 other words that mean x-intercept? If you go back to your classroom, and all of our classes are the same. Ms. Foy's class, Mr. Slagle's, we all have the same things to help you guys. There's no different notes. We all try to use the same thing. So if you go to your notes, we provided y'all with a couple of these notes. And if you look, right at the bottom of this page where it says x-intercept, it's circled, or it's got the pink square around it. Right there on your notes that are provided for you, it tells you what other names there are for x-intercepts. Those are the only other 3 that are listed there. That's it. So make sure you're looking at the PDF notes that are provided for you. They are there to help you. And and if you look, they talk about everything that I just talked about. Please don't write goat. We do have people, Coach Hendrick told me that we do have people just randomly selecting answers. Guys, this stuff isn't that bad. Please look at what you're answering. Never in our life have we graphed goat. All right. I believe that is it for this. Again, if you need help, make sure that you watch the video all the way through. And then what I'm looking for is somebody to ask me in the Google Classroom, hey, I looked at the video, I looked at the notes, I'm stumped still on number 3. Can you please either send me a video, or we can Zoom together? I'll do whatever needs to be done to help y'all get through this work, okay? So just send me a Google Classroom comment, and I'll get you the help you need, okay? Hope everybody has a good day. Thank you.